Hello. In this example, we're going to consider the polynomial function f of x equals 6x to the fourth plus 7x cubed minus 12x squared minus 3x plus 2. A says to list all possible rational zeros, and then B says to find all rational zeros and factor f of x into linear factors. Now then, to do this, what we're going to do is we're going to use what's called the rational zeros theorem. It says that all rational zeros are in the form of p divided by q, where p is a factor of the constant term and q is a factor of the leading coefficient. Now, this rational zeros theorem only finds all the possible rational zeros. By rational, we mean fraction. If it's an irrational number or a non-real complex number, it will not be in this set. However, we can use this to find possible rational zeros. Okay, again, so here's the function f of x equals 6x to the fourth plus 7x cubed minus 12x squared minus 3x plus 2. This is the function. We want to find all possible rational zeros. So to do that, we need to figure out what are all our possible p's and q's. Now, p is associated with which number here? Remember, p is the constant term. It's a little bit off from what you might be expecting. It's always the last term here, although p comes before q in the alphabet. So p is associated with 2, and q is the leading coefficient, which in this case is 6. They're kind of flipped from what you might expect. And what I like to do is I like to write down the actual factors of each of these. The factors of p are 1 and 2, and the factors here for q for 6 are 1 and 6, 2 and 3. So those are all of the factors of the constant term and the leading coefficient. Now I need to look for every possible p divided by q. And what I'm going to do is I'm going to start out with the p being 1. So 1 divided by, and I'm going to divide it by each one of these for the q. So 1 over 1, 1 over 2, 1 over 3, and then 1 over 6. And then I'm going to go to the next number for the p, and that's a 2. So it's 2 over 1, 2 over 2, 2 over 3, and then 2 over 6. And at this point, you simplify and write down the numbers, but only write them down once. For example, 1 over 1 is just 1. 1 over 2 is a half, but I haven't written it down before, so I do need it. 1 over 3 is a third, and I haven't written it down before, so I still need it. And then 1 over 6 simplifies to 1/6. Then you have 2 over 1, which is 2. 2 over 2 is 1, but I already have it, so I don't need to write it again. 2 over 3 I don't have yet, so I do need it. And 2 over 6 is 1/3, so I don't need it. I've already got it. So these are all the numbers except for one thing. I haven't taken into account any possible negative values. So each one of these can be either plus or minus. So it's plus or minus 1, plus or minus a half, plus or minus a third, plus or minus a sixth, plus or minus 2, and plus or minus 2/3. Put these in curly brackets to make them a set, and there you go. This is the list of all possible rational zeros. Now here's the thing, not all of these will be a zero. And so what we could do is we could just start guessing random numbers in here to determine if they're zeros of this polynomial. But that's a little bit time consuming and honestly a little bit annoying. So the question is there a way of figuring out B without having to just randomly guess numbers? And the answer is yes. And I'm using the word cheat here loosely. We're not really cheating, but we're using our technology. And the technology that we're going to use is a calculator. And yes, you have a calculator for a reason. So what we're going to do is we're going to go to the calculator and we're going to type this function into the calculator underneath y equals. So if you go to y equals, type in 6x to the fourth plus 7x cubed minus 12x squared minus 3x plus 2. So for me it's 6, and then the x is right here, x to the fourth, so caret 4. Now if you have a 84 or one of those newer ones, you have to go to the right to get back down here. If you have an older, say an 83, you don't have to do this. And then plus 7x cubed, again caret 3, and again I'll need to use the right arrow. Now notice that we have to use a minus. It's not the negative sign, but the minus. Minus 12x, and then I can just use this for squared. Then minus 3x and plus 2. And if you want, you can graph it, and it will graph the function. This is about what it looks like. And notice that there are, in fact, 4 zeros here. So that's how many factors we're going to need. But to see any of these, what I want to do is I want to go to the table. So if you go to second table, this is probably what you're going to start seeing. But the question is, how do you determine what's a zero and what's not? Remember, the definition of a zero is wherever it crosses the x-axis. But what's that y value on the x-axis? Well, that's 0. So if you go back to the table, look for any y values being 0. In this case, that shows that -2 is a 0. So what we're going to do is we're going to use -2, and we're going to prove that -2 is a 0 using synthetic division. So -2, synthetically divide all of this. So that's a 6, excuse me. All right, there we go. So we have that 6, 7, -12, -3, 2. Bring down, multiply, add, multiply, add, multiply, add, multiply, and add. Fantastic. Notice that we got a 0 there. That's good. That shows that -2 is a 0. It's very important to actually show that. Now, notice that because -2 is a 0, that means that x plus 2 is a factor. Okay? But that wasn't all of the zeros that we found. If you go back to the calculator, notice that there's another 0 on the y here at 1. So I'm going to prove that 1 is a 0 as well. But notice that I'm not starting over. I'm just going to continue with all this. Because whenever you factor out the x plus 2, these are the coefficients that are left. So I would need to have the zeros of that polynomial there. So I'm going to use 1 here to prove that 1's a 0 of this polynomial. Bring down the 6, multiply, add, multiply, add, multiply, and add. Fantastic. We've just proven that 1 is a 0, and because of that, that means that x minus 1 is a factor. Now, we have 6, 1, and -1. Anytime you have 3 numbers like that, this is a quadratic. So if you look at this, it's actually 6x squared plus x minus 1. And you can factor that. In this case, you're going to have a 3x here and a 2x here. One's positive, one's negative. But notice that there's just a 1 here, and that means there's always a 1 and a 1. That's the only way to make a 1. So the reason this is actually not that difficult. So because of that, we need a positive here and a negative here. And the reason why is because 1 times 3x is positive 3x, and negative 1 times 2x is negative 2x. So positive 3x minus 2x is that positive x. That's that middle term there. So that's the factorization here. Now notice, I'm just going to kind of write this over here, the 3x minus 1 and the 2x plus 1. And I'm going to erase this stuff here. Okay. What I could do instead is I could actually prove that this 3x minus 1 is going to give me a 1/3, and the 2x plus 1 would give me a negative 1/2 if I set them equal to 0 and I solved. But I can actually see that using the calculator as well. Now, you can't see it here because these go by ones. So what you can do instead, if you go to second calc, which is right here, notice that number 2 is a 0. We can find zeros like this. So if you do 2 or go down and click enter on the 2, notice that it says left bound. And notice that I've already found that negative 2 and I've found the 1, but I haven't found these two numbers here. So I need to be to the left of this 0 right here, which means go below the x-axis, which means somewhere over here. Just press enter. And then go right until you're above the x-axis, which means fantastic. I'll click enter, and it says guess, so I'll click enter again. Hey look, negative 0.5. Negative 0.5 is actually negative 1/2. Fantastic. So what I'm going to do is I'm going to prove that negative 1/2 is a 0 here. Bring down the 6. Negative 1/2 times 6 is negative 3. 1 minus 3 is negative 2. Negative 1/2 times negative 2 is positive 1. Fantastic. That's a 0. And notice that this is 6x minus 2. So you can use that to show that x is a third, or I'll just use it this way. Bring down the 6, multiply, add. Fantastic. So we've got 4 zeros here. Negative 2, 1, negative 1/2, and 1/3. Now notice that this 6 down here is just a constant. Okay, so remember that we had x plus 2, x minus 1, 3x minus 1, and 2x plus 1. All of those are the factors of this polynomial. So really what you could have done, you didn't have to do any of this extra down here. You could have written down the factorization as x plus 2 times x minus 1 times 3x minus 1 times 2x plus 1. And that is the factorization. That's perfectly fine. Let me do that a little bit better here. There we go. But there's another way of doing this. Now, yes, negative 2 gives me x plus 2. 1 gives me x minus 1. But negative 1/2 means x plus 1/2. And 1/3 means x minus 1/3. So what I can do instead is I can write down the factorization as the first one up here, x plus 2. The second one was x minus 1. Now from this negative 1/2 that gave me x plus 1/2. And then the x minus 1/3 here. But this is not this yet because I still haven't accounted for the leading coefficient. So really you can just write that number down. So this is a couple of different ways of factoring this polynomial. So either way, it doesn't really matter. It's up to you. Alrighty. Well, I think I'm going to call it quits here for this problem. I will see you next time. Have fun.